welcome back. So what we're looking at today is 4.1, some of this, some of that. So let's go ahead and jump right in. So what we're looking at here is what's known as piecewise defined graphs. So reading function values in a piecewise defined graph. So use the graph to find the indicated function values. So we have all of these graphs, and then we have all of these values that we want to find. So we're going to do number 4 together. So number 4 here is a piecewise function because we've got all these different functions happening. We've got a quadratic here in the middle, we've got a linear equation here, and we've got another linear equation here. So what we're looking at is it's saying r of -3. So that means for all of these, start with your x values. So we're going to go over -3. So 1, 2, 3. So this is -3. And then we need to find what the y value is here. So we're going to go up 1, 2. There is our value where r, the function, is -3 for x. The input is, or the output, is 2. So our y value is 2 when x is -3. Now, when x is -1, well, we go over 1. The function is right here at +1. Now for r of 0, we look where x is 0. Well, guess what? Y is also 0. And then for the last one, r of 5, we go over to +5. So 1, 2, 3, 4, 5. And then we are going to go to find our function, which is up 1, 2. So there are values. So for the other 3, you are taking the number that's inside the parentheses. That's your x value. Your x-axis is the horizontal axis. You're going to find the x value and then figure out what the y value is for that x value, okay? All right, the next section. Isaac lives 3 miles away from his school. School ended at 3 p.m., and Isaac began his walk home with his friend Tate, who lives 1 mile away from school. 1 mile away from school, in the direction of Isaac's house. Isaac stayed at Tate's house for a while and then started home. On the way, he stopped at the library. Then he hurried home. The graph at the right is a piecewise defined function that shows Isaac's distance from home during the time it took him to arrive home. So how much time has passed between school ending and Isaac's arrival at home? So this is time. So this is how long it took. So if we look, he got home at 3 hours, 3 and 3/4 of an hour, so 3.75 hours. For B, how long did Isaac stay at Tate's house? Well, we're looking at distance. School is 3 miles from school. So we're at 3, we got down to 2, and then he stops. So Tate was 1 mile from school, so from 3 to 2 is 1, so we know we're at Tate's. They got there at a half hour in, and he left at 2.5 hours in. So how long did he stay there? For 2 hours. The next one, how far is the library from Isaac's house? Well, he went from Isaac's house. So he left Tate's house and went to the library. So the library is here at 1.5. So it's 1.5 miles. So you guys are going to finish out the rest of these using this piecewise graph over here. So piecewise is your key word for this lesson. Piecewise. All right. The next section is looking at writing piecewise defined functions. So we are going to look at number 7 because it's more complicated. So Lexi completed an 18-mile triathlon. She swam 1 mile in 1 hour, bicycled 12 miles in 1 hour, and then ran 5 miles in 1 hour. The graph of Lexi's distance versus time is shown. Write a piecewise function, L of t, for the graph. So L of t. And then we're going to have 3 separate functions because we have this function right here, this little line. Then we have from this point to this point is another function. And then the last part is this up here. So there are 3 functions here. So for the first part, it tells us that she swam 1 mile in 1 hour. We can tell what the y-intercept is. It's 0. So up 1 over 1, it's just going to be t. For the interval, 0 is less than or equal to t is less than or equal to 1, because this is the function where x is 0 and 1. Now, we need to worry about the second one. So it tells us she biked 12 miles in 1 hour. So what's our slope? 12 divided by 1 is 12. So we have 12t. But we need to figure out what the y-intercept is, because notice it's not crossing the y-axis yet. So if we go down 12, so this function is up 12 over 1, if we reverse that and went down 12 into the left one, we'd be on the y-axis. Here, we're at positive 1, so if we go down 12, we'll be at negative 11. So our y-intercept is negative 11. So 12t minus 11 is our function then. And this function goes from when x is 1 to x is 2. So this is 1, hang on. From 1 is less than or equal to t is less than or equal to 2, because you have to have the intervals for piecewise functions. These intervals are crucial to writing piecewise functions. If you just write the equations and that's it, well, then the equations exist over the whole entire thing, which isn't true. They only exist over certain intervals, and it'll completely change a problem. So now for the third function, she ran 5 miles in 1 hour. So what's her slope? 5 divided by 1 is 5. So we've got 5t. Now we need to figure out the y-intercept. So if we reverse this, down 1, 2, 3, 4, 5 over 1, down 1, 2, 3, 4, 5 over 1. So her y-intercept is a positive 3. Now this one is going from when x is 2 to x is 3. So 2 is less than or equal to t. It's less than or equal to 3. So there is our function. Like I said, 6 is going to be a lot easier. One of your equations is just going to be a constant, so it's just going to be 3. And then your other function will be this one right here. Okay? So you'll just have 2 functions for that one to worry about. All right, and the last section, we want to write the equation of the line in point-slope form that contains the given slope and point. Remember, point-slope form is y minus y1 equals m times x minus x1. So we are going to look at number 8. So we have the point 1, 2, and we have the slope 3. We're just plugging these values in. So we're going to have y minus 2, because 2 is our y value there, equals 3, because that's what m is, parentheses, x minus 1. Because remember, our ordered pairs are always in the order x, y. This x right here and this y right here will always stay x and y. Do not change them. Now, this part down here, same thing. We're still going to put them in point-slope form, but we have to find the slope first. So we're going to look at number 12. Remember, to find slope, it's m equals y2 minus y1 over x2 minus x1. So for this is x, y, x, y. So we have negative 1 minus 7 over 3 minus negative 1. Negative 1 minus 7 is going to give us a negative 8. 3 minus 1 is going to give us 2. 3 minus negative 1, is 4. Negative 8 divided by 4 is negative 2. So that's our slope. So now we have y minus. Doesn't matter which x and which y you use. You just have to use one point. So I'm going to use this one right here. So y plus 1 equals negative 2 times x minus 3. So that's one possibility. Your other one could have been y minus 7 equals negative 2 times x plus 1. So you could have either of those. So there's 2 options for both 11 and 13 as well. So if you guys have any questions, feel free to ask. Have a great day, guys. Bye.